generally they'll ask you the question, what are the different types of transformer? First category is based on the construction. Okay, this is based on the construction, will have different category. One is the core type and another one is the shell type. Core type is just like this. I explained you like this. Okay, here basically there are two types of winding. One is the primary winding, which is created in the upper limb. This is technically known as upper, and one is the secondary winding. This is created on the lower limb. In the primary winding, we have connected the voltage supply like this, and in the winding, we'll connect the load like. Okay, understood? Now here we'll give the voltage V1, and here the current would be I1. The number of turns would be N1, and in the secondary side number of turns would be N2. The current flowing in the load is I2, and here the EMF is induced. EMF is E1. Here the EMF is induced is E2. Got it? And in this case we'll have particular formula that how much is EMF induced in the transformer, that is E1 it would be equal to 0.44 N1 F phi M, where N1 is the number of turns in the primary winding, right? And F is the frequency of the circuit, and phi M is the maximum flux of the transformer, which is distributed evenly in the core of the transformer. Got it? Similarly, we'll have E equal to 4.44 N to F phi M. So phi M is again maximum flux. If EMF is induced in A2, that will depend on N2. If EMF is induced in N1, then that will depend on N1. So E1 is known as self-induced EMF, and E known as mutually induced EMF. Got it? E1 is known as self-induced EMF. Like suppose you are giving voltage to the primary winding, and EMF is always induced in the primary winding. Then in that case, that is technically known as self-induced EMF. Okay? And if you are giving supply to the primary winding and automatically EMF is the secondary winding, then that is known as mutually induced EMF. Got it? So if I'll divide these terms, like E by E1 would be equal to 4.44 N2 F phi M divided by 4.44 N1 F phi M. All these terms would be cancelled out with each other, right? Come E by E1 would be N2 by N1, correct? And if by E1 is there, then we can write down V by V1, and voltage is there, current would always be opposite, then that would be I1 by I2 equal to. This is technically known as transformation rate. Whenever they'll give any kind of transformer question, you have to write down the transformation ratio as, okay, as transformation. Understood? Now this is the kind of transformer. One question they'll ask you that on which principle it works. So basically it works on Faraday's law of electromagnetic induction. What does Faraday law states? That is E equal to minus n phi by d phi by dt, that is change in flux with respect to time. Respect time. So Faraday states only one thing, that if there is change in flux with respect to time, then only in that case EMF will induce. If there is no change, no EMF, right? So how will this flux change? Flux mainly depends on current. Okay, current AC doge, changing current, then flux also keeps on changing. If current you are giving the constant, flux would be constant. That's why we always say that transformer never works on DC, right? Transformer always works on AC because in AC current is changing, so flux keeps on changing. If flux keeps on changing with respect to time, then in that case EMF will induced in the transformer. Got it? Now we'll have another types of transformer. One is the auto transformer, another one is the three-phase transformer. Three-phase transformer means in the primary side will have three-phase connection and secondary side will have phase connection. Okay, so as you know, phase we have divided into category star and delta. So it can be star star. That means ki primary is also connected to star and secondary is also star connection, or it can be star it the star, or it can be delta delta, right? So basically there are four possible combinations. Are the different category of phase trans. Got it? Now, auto transformer. What is the difference between the normal transformer and the auto transformers? In the normal transformer, we'll have the types of limbs like primary as well as secondary, right? But in the auto transformer, we'll have only the single winding. If we have connected this to the primary side, then that will become the number of turns N1, and we have done tapping at the second side and single winding. As you can see that we have used single winding, and single winding we'll use in the primary side as well, and single winding we are using it as the secondary side, right? So in this V1 is given, I1 is given, I2 is given, N1, and here the number of turns is N2. So now can you tell me this auto transformer is working as a step up transformer or step down transformer? Number of turns is less than number of, so it will work as a step up transformer or step down transformer. Yes, a step down transform. Got it? Work as a step down transform. It's not like auto transformer always works on step down. It can be worked on step up also, depends on the configuration. So what is the main difference? Construction difference is there, but working principle is same to the normal transformer. Generally, we'll use auto transformer at our home appliance like refrigerator, or we can regulate the and normal transformer is used for the power system structure like these transformers. Got it? Now see they have shown the diagram primary winding, secondary winding, and this one they have shown the both the transformer. This is step down transformer and this one is the step up transformer. You can see the diagram from this PDF, right? Now the another kind of transformer is power transformer and distribution transformer. As I told you earlier that power transformer in the single line diagram, remember I told you that we have to use it like from 11 kilovolt to 20 kilovolt. We are using the transformer, right? And it is increasing a very high amount of voltage. So that kind of transformer is known as power transformer. Yeah, the transformer which is used to increase a very high amount of is known as power transformer. Now the distribution transformer which we are using at the side, like suppose nearby to your homes, we are using distribution transformer that is used to convert a low amount of voltage from simple 11,000 volt to 220. Understood? So basically power transformer is used to change high amount of voltage. Okay, and distribution transformer is used to change low amount of voltage. Basically, as you know, power transformer will use in transmission network, right? Because we need to increase high amount of voltage in transmission, and in distribution transformer will use nearby to our home. Next category of transformer is CT. Remember I told you that they are used in a substation also. So basically it is used for the measurement. Like for generally what will use for the power, what will use for the voltage measurement? Voltmeter, right? And what will use for the current measurement? Ammeter, right? But do you think that there is such a high amount of voltage can for the voltmeter? It's of volt. And if we want to measure 440 kilovolt, 765 kilovolt, then can we use voltmeter? No, na. So for that, we'll have two different transformer: potential transformer, and CT means the current transformer is used for the value of current. Okay. Again, CVT function is also the same. It is used the voltage regulate. Isolation transformer means they'll have the same winding. N1 is always equal to, but we'll use it for the separation purpose. Okay, so this is all about the